Hello everybody, this is Unit 8 Learning Target number 4, adding and subtracting radical expressions. So, what we need to do is first simplify our radical expressions so that way they have the same radical. You'll see up here, both of these have square root of 2's, so they can be subtracted from each other. But on the second example, this expression has square root of 2 and this has square root of 7. They cannot be subtracted from each other. Let's look at some examples. This first one up here, 2 square root 2 plus 3 square root 2. Well, you can see that they both have square root 2 at the end, which are the same. So we can add them together. So just 2 square root 2 plus 3 square root 2. We just add the 2 and 3 together, which will give us 5 square root 2. You can kind of think of it like an x. Like if we had 2x plus 3x, would give us 5x. As long as the term is the same, then they can be added together. Now let's look at this problem. So over here we have 4 square root 3 minus 2 square root 3. And notice both of them have the square root of 3, which is the same term, so we can subtract. 4 minus 2 is just 2 square root 3. That is our final answer for both of those. All right, up here, we're going to look for the common radicals, okay? So I see square root of 10 here and square root of 10 here, and then 2 square roots of 7. So we're going to add these 10s together. So we have 2 square root of 10 minus square root of 10. Now there's not a number in front, but we know that there is an invisible little 1 right here because there's just a single square root of 10. So 2 square root 10 minus 1 square root 10 is going to leave us with 1 square root 10 plus, we'll look at these square root 7s now. We have a 3 square root of 7 plus 2 square root of 7. And 3 plus 2 is going to equal 5 square root 7. These 10 and 7 are different, and they can't be reduced or simplified to a common term, so this is going to be the final answer. Over here, we're looking at something very similar to the last one. We have 2 square roots of 13s and 2 square roots of 17s, which are both prime numbers, so they can't be simplified at all. We're going to look at the 13s first. We have a 9 right here, minus a 2, so 9 square root of 13 minus 2 square root of 13 is going to equal 7 square root of 13 plus, now we're going to look at the square roots of 17s. We have 2 square root of 17, actually I'll do this in a different color. We have 2 square root of 17 minus our 1 square root of 17, and 2 minus 1 is just going to be 1, so we have plus 1 square root of 17. And again, these terms cannot be reduced or simplified because they are both prime, so this is your final answer. All right, for these problems, you're going to see that the radicals are different from each other, so we can't add them together yet, but they are not prime, so we can reduce them. So first we're going to look at square root of 72, and we are going to split this apart. I see that 72 can be divided by 8. 72 divided by 8 is 9, so 8 splits into 2 and 4, 9 splits into 3 and 3, 4 splits into 2 and 2. So I see we have a pair of 2's and a pair of 3's. So we're going to multiply them together. 3 times 2 equals 6. So 6 is going to be on our outside. And then what we have left is this 2 right here. So we're going to have 6 square root 2. It's going to be equal to our square root of 72. So now we are going to look at the square root of 50. So I see that it's divisible by 5. And 50 divided by 5 is 10. 10 splits into another 5 and 2. And these are all prime numbers, so now we just circle our pair of 5s, which means that there's a 5 on the outside, and on our inside we have square root of 2. Write this down here, 5 square root 2. So now that our radicals are the same, we can add these together. 6 square root 2 plus 5 square root 2. 6 plus 5 is going to be 11 square root of 2. That is your final answer. Now over here, we're going to be doing something very similar. 192. I know that 192 is divisible by 3. And once divided by 3, it is divisible by, it equals 64. 3 is prime, so there's nothing else there. 64 splits into 8 and 8, and that is a pair right there. So we are going to have 8 square root 3. All right, minus, we're going to look at this, square root of 75. I know that this also splits into 3 and 25, and 25 splits into 2 5s. These are all prime, so we'll circle that pair. We have 5 on the outside, square root of 3 on the inside. So I'll put this over here. 5 square root of 3, or 8 square root of 3 minus 5 square root of 3. 8 minus 5 is just 3, equals 3 square root of 3. And that is the final answer. All right. So now you can see that this first term already has square root of 3 by itself, and square root of 3 is prime, so that can't be simplified. So we're just going to be looking at this square root of 27 to simplify. I know it simplifies by 3. 27 divided by 3 is 9. 9 splits into 3 and 3. That's a pair. These are all prime now. So we have 3 on the outside, inside square root 3 from right here. And now we'll take our initial term, which is 4 square root of 3, minus sign, so we're going to minus our new term, which is 3 square root of 3 equals 4 minus 3 is just 1, square root 3 is going to be the final answer for that one. All right, now over here we see that this 2 is prime and can't be simplified anymore, so we're just going to be looking at the square root of 18 right here and split it apart. I know that 18 is divisible by 3 and 6, and 6 splits into 3 and 2. Now that these are all prime, 3's match up, so they're going to go on the outside, and then inside is left with square root of 2. But now, before we add it with our other square root of 2, can't forget this 2 on the outside. So the 2 is going to multiply with the 3 that is already out here. 2 times 3 equals 6 square root 2. So now we're going to take 6 square root 2 plus this square root of 2 from right here. And our final answer will be 7 square root 2. All right, last page. We're getting some of the tougher ones. So here we go. I'm going to scan this problem real quick. I see that this term has square root of 5 in it, and 5 is prime, so it can't be simplified. So we're going to simplify the other ones first. We'll start with the first term, which is square root of 125. I know that splits into 5, and 125 divided by 5 is 25. That breaks into 5 and 5. These are all prime now, so we'll circle that. And we have 5 on the outside from this pair, and then this 5 is left over, so that's going to be under the square root, plus this term right here, which can't be simplified anymore because it's already prime, plus square root of 45. But first we need to simplify it before we can add the rest of it. So 45, I can see is divisible by 5, and would also be then 9. 9 breaks into 3 and 3. That's a pair. So we're going to have 3 on the outside, and what's left over is this 5 right here, goes right there. So now we're just going to add these 3 terms together. 5 plus 4 is going to give us 9 square root 5, plus this 3 square root 5, 3 plus 9 is 12, square root 5. Final answer. All right, last one. So I'm going to do a little scan. I see that none of these are prime, so we're going to start with the first one, square root 12, and break this apart. I know that it is divisible by 4 and 3. 4 breaks into 2 and 2. That's a pair. So we know that this term is going to be 2 on the outside, 3 on the inside. But we can't forget about this 2 right here. It's going to multiply with our 2 on the outside, which will give us 4 square root 3. Okay. Now minus this next term right here. I'll use a different color. We have square root of 27, which is going to split into 3 and 9. 9 will break into 2 3s itself. That'll be a pair. So we're going to have 3 on the outside and the square root of 3 from right here on the inside. But we cannot forget about this 3 on the outside. 3 times 3 is going to equal 9 square root 3. And it's minus here because of this sign right here. All right, so now we're left with our last term, square root of 48. This is going to break into, let's see, 4 and 12. 4 will break into 2 and 2, 12 into 4 and 3, this 4 into 2 and 2. So there's a pair of 2s, another pair of 2s, and what's left over is a 3. So we're going to have 2 times 2, because these two pairs right here, times 2, square root of 3. It's going to give us 4 square root of 3, but we cannot forget about this outside term. 4 times 2 is going to be 8 square root 3. And we'll just add that to this equation right here. Okay, so now we just add the terms together. 4 square root 3 minus 9 square root 3. 4 minus 9. The 9's bigger, so we're going to have negative 5 square root 3 plus 8 square root 3. So negative 5 plus 8 is going to be the same as 8 minus 5. So we will have 3 square root 3 as our final answer. There you go. I hope you guys enjoyed, hopefully learned something, and catch you in the next video.